Hello, everybody. Good afternoon to you. Just waiting 1 minute more. Okay, let's start. So, hello again. Good afternoon to you. Again, we are here for the third day presentation of our training course. And again, it's a pleasure to be here. And thanks all you, and thanks to Afro to promote this. And today in this session, we will talk about the Industry 4.0 and the digitalization. Actually, these words, it's been talked, and this is the most part of the automation and the IT industry that we are talking about. So let's start. Today, we will see an overview. This is the program for today. We will see an overview of the concept of Industry 4.0, MQTT, an overview and the advantages. We will talk a little bit about the OPC UA and the MQTT, the main protocols used in the, oh, sorry, here, let me just pick the pointer here. Thanks. We will talk a little bit more about the OPC UA and MQTT, the main protocols that we are using in the Industry 4.0. We will see an application, an MQTT application. I prepared something to show you. We will talk a little bit about our SQL database library and application, how to connect. We will do a web server training inside. We call the WebVisu feature inside the Express, and we will do this a little bit about hands-on practice and some application success stories about the Industry 4.0 and the applications and information to the cloud and receiving these in the dashboards and so on. Okay. So let's start with an overview of the concept of the Industry 4.0. Well, new challenge of industrial automation, this Industry 4.0. Let's a brief introduction about the Industrial Revolution. We talk about the Industry 4.0, but what is the older or oldest industry that we pass, and then the modernization that we face in the world. So the first, the Industry 1.0, it's the mechanization, 18th century, where artisanal to industrial work, steam machines, and we had the first factories. 2.0 industry, the electricity. So in the beginning of the century 19th, electric power in industry, Taylorism, and the Fordism. The 3.0, the automation, 20th century, with the creation of the programmable logic controllers, industrial PC, to support and to do this movement inside the automation, inside the industry to gain productivity and more safety, of course. And the Industry 4.0, we are talking about the smart factory in the 21st century, Industrial Internet of Things, IIoT, communication and collaboration between machines, customizing small production batches. But what is the Industry 4.0? Actually, this expression is born in some fair and some exhibitions and some especially centuries that we have in Hanover Fair Trade 2011, Acatech paper 2013, German government incentive companies plus university plus research, and we had the paradigm change. The concept proposes a complete decentralization of the control of production process and a proliferation of interconnected smart devices through the entire production and logistics chain. So we had the integration between products, technologies, companies, and people. But how? Through the integration between products, technologies, companies, and people. So what we have? Smart homes, social web, Internet of People, business web, smart logistics, Internet of Service, the Internet of Things, smart mobility, smart grid, and the Internet of Data with smart buildings. So, join everything of this, we have a smart factory. What is the benefits? We had the efficiency growth, complex products, short innovation cycles, and production flexibility. What is the Internet of Things? Physical cyber production system with intensification of information and direct communication between systems, machines, products, and people. This is an example of a building automation. We have this applied at Altus building. We have an Alexa connected to the cloud, sending information to our SCADA, the blue plant, that connect next to PLC, then actuate in the lamps, valves, air conditioning, and so on. Another point, and we will talk about this, is the direct database access. Supervisory system with native database not requiring the use of a third part. Programmable controllers, PLCs, can read, write values directly to the database. In this way, it is possible to integrate the factory floor with the company's management software, the ERP. Another point, and we will talk a little bit about this, and we will produce, it's the embedded web server. For small applications, the POC themselves can now access screens for access in real time using web browsers. And so you can operate and monitoring without using an HMI or a SCADA systems. Okay, but to talk about the Industry 4.0, of course, we need to talk about the MQTT. So we will see what is the MQTT, an overview and the advantage of using this protocol. Here we have a fast question and answer about MQTT. What is the MQTT and what means MQTT? It is a simple and lightweight messaging protocol. It means message, queuing, telemetry, transport. Who invented the MQTT? IBM and Arcom. When was MQTT invented? In 1999. So here we can see that MQTT is not that new as many people think that is. Where is MQTT used? It is used in application where it's necessary to connect device to network with limited availability and low bandwidth. What are the main components of MQTT? The clients and brokers. Is MQTT a standard? Yes, it is listed at WASIS, Open Standards, Open Source here, and the ISO 2. Well, let's talk a little bit about the broker. What is a broker? The broker is the software responsible for managing clients' publications and subscriptions. It is like a kind of mediator between the clients. The clients, I mean the device, able to make the communication actually happen between them. We can compare it with a post office that routes packets between the different clients connected to it. So here we have a device that's sending message in this topic. So I publish in topic, temperature, and send this information to the broker as the post office. And when a client connect and ask for topic temp, the post office will send the message. So I subscribe this, I assign this topic, and I will receive. Every time this information changes here, the client will receive here, and the broker do this management of this communication. Well, the main advantage about MQTT, cybersecurity. MQTT is embedded TLS, Transport Layer Security, CA files, Certificate Authority in client and broker, and of course, user and password. Here, just to compare, the traditional communication between SCADA, for example, using traditional protocols, every device can connect to every device, but as straight device, so as straight communication. So I need to take care about the security here, 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 here. If we compare with the topology and architecture of the MQTT broker, you can see that if I protect the broker, I can manage every connections here and using these TLS, CA files, and of course, user and password inside here. So it's much more easy to manage these than this for a safety view, for a cybersecurity view. Here, another main advantage, easily scalable. So we can publish information here, and here we have 3 clients that can consume. If I add another client here, I will, and of course, subscribing this same topic, I can receive this information in this new client. So we have an architecture one-to-many. And the opposite is true too. So we have many-to-one. For example, I'm programming these 3 devices to send information, these at time 1, these at time 2, and this at time 3. And I will receive in this client every time one temperature from one of these clients, and one of these 1 hour after, and one of these 1 hour after. And of course, every time I receive the information in the post office, in the broker, the client will be updated. So you can centralize clients, connections, management. So here we have publish and subscribing, push button and light device, and we can connect more push buttons and more light device here, and just changing, for example, the topics from each one. I will send all information and concentration these here and can share with the other ones. Here, the reduction of the amount of data to travel on the network. It is a publish subscriber protocol. So the client can be programmed when publish a new message. So for example, I'm programming this device to send information about the temperature at this time and disconnect this transmitter to, for example, safe battery. When the client connects here, this information, the last one information, will be stored at the broker. And when I ask for this package for this topic, I will receive, even if this device is not connected at this time. So I can program in this. And again, if this information is here, if I connect other clients here and ask for the same topic, this new device will subscribe and receive the information to this broker. Of course, following the rules and the policy of the cybersecurity. But I can connect and I can receive. Here, just a little bit of a small comparison, and then that actually not a comparison, but show the main difference about these 2 protocols and talk exactly about why these protocols it's very used in the industry 4.0. So OPC UA, client-server architecture, it allows greater interoperability and security since it is formed by point-to-point connection. However, these connections are not very scalable due to the need for connection management and use of computational resource. The MQTT, it's a kind of publish and subscriber architecture. It allows for greater scalability because it decouples consumer sensors, which can be inserted or removed independently, ensuring security in this case is more complex, as there are more points involved and connected. There are also interoperability problems once a data generator changes the message format. Here, just a picture to show the main difference. We have OPC server and OPC client, and one very nice feature in the OPC server that the OPC server can connect to other OPC server because they have client interface inside the OPC servers. So you can do this. And here, as we saw before, we have the traditional publish and subscriber. Here is the publish, And here is the subscribers information using the MQTT broker to manage this. So after seeing their main characteristics, both protocols are what drive in terms of Industry 4.0. Trends in new protocols should emerge as alternative in a short period of time. But today, we can say that these two protocols are dominating the 4.0 industry. The conclusion we reached is that each protocol should be used for what it was designed for, and both can be used together. This is very, very important information. MQTT for device with low resource, low bandwidth networks and high latency, or in applications that require the flexibility of this protocol, and the OPC UA for industrial environments, since it seeks to unify the way of operation with different manufacturers of industrial device, being a complete solution that covers from the communication of the device to their interoperability. In those environments, the increase in bandwidth consumption is not as critical, and it compensates for all the advantage that OPC UA can bring us. Okay, let's pass to an MQTT application here. Actually, this is the architecture that we are using here in this case. We have, for example, an Express here with me, and it's connected, publish subscriber connection here to a Mosquito that is running in a Azure, Microsoft Azure Altus. So just to show you the architecture that we can develop, and we are using an Express to connect it to the broker. In this case, we are using the Mosquito. It's a kind of broker. This Mosquito, this broker, can connect directly to a database here. And this Mosquito can be connected with web service tools. In this case, we are using the Node-RED, okay? Here, an example using a SCADA system at the cloud, connecting. And again, we can connect using the Mosquito broker. So a SCADA receiving information from an Express using MQTT2. And here, another example of the architecture where we have the Express connecting to the DB database using the SQL library, Microsoft SQL library that you will see later. And of course, clients here from the Node-RED, that it's the client MQTT and can share information, and you can build dashboards inside these web service tools. In this sample that we will see, it's the Node-RED that we are using. And of course, using information at the Node-RED to send Telegram and connection to HTTP. So for this application that we will see, we are using the MQTT library inside Express, a Mosquito broker, and a Node-RED inside. And actually, it's an Azure virtual machine that we are using. We have the Amazon, but I prefer to use the Azure. And the web browser to access the dashboard that we created at Node-RED. So it's very simple. I send information through the MQTT to this broker, and this Node-RED is connected to this broker and can share information with you here. This address, it's the address that I will show you, the dashboard that we built. So here we have the dashboard, very simple dashboard.
Yeah.
And what we have here, basically, it's some alarms that I created here. And some commands to start a pump water and a compressor, totally hypothetically, and simulating here. Some readings of my analog inputs, some pump hours. So the first point is I will start my pump water, and you will see that this hour it's counting. And here I can share with you the master tool connection. Just close this and open. For example, I'm publish information. So I need to find exactly these hours. And you see that we have 19 here, 20, 21, 22. So I'm connecting to my Express that I have here. And I will show, for example, this publish, the topic number 1 that I call digital input 0. So now it's false, and I have a F here for false. And now I change this to true, and you can see here that isn't true. The second one, I will change now for true. It's in a new topic, so the IE01. I will change again this to false, and you can see here that is false. Of course, for the other ones, I have 2 here and here. All alarms in true. Here, I'm publishing, for example, the analog input, 0. So I will move the potentiometer that I have here, and you see that CO2, it's increasing. And this is sending, this information is sending here. So I'm moving the analog input here, and the information is sending. Now, what I will do is this. I will copy this and share with you in the chat here to everyone. So you can access this, and you can operate my system here. So you can turn on and turn off, power on and power off the compressor. If you connect here at the link that I sent to you at the chat, you can, please, someone turn off my pump water, please. Okay, thanks. Let me just show you where I received this information. Here, my Q00 is my first digital output. So, and here I have this. Okay, thanks a lot. Somebody power on, turn on the Q01, the compressor. So you can now power off again to check this and this. It's what I'm receiving here straight to the controller that I have here in my hands. I will move this to show another analog input, I'm sorry. And you can see, and I'm moving. Now, what I will do is this. I will enter at this program organization, this subroutine here, and I will disable the connection that I'm doing here at this broker 40.85.179. It's the same one that we have here, and I will disable this. So I will disconnect. Now, of course, you can press information, pump water and compressor, but I can send, you are sending information to the Mosquitto, but I can't send any more information because I'm not connected at this. So I change here, and you see that the values here, for example, at the publisher, it's not being updated. I will pick, for example, the first digital input. It's in true here to me, and it's true here, and I will false, and it's not sending information. It's in true. But if I connection again here and checking the connection here, okay, it's connected, and we have no error. And I change this information. You can see here that I changed to false. Okay, just let you know, this library here can present you. This library it's available at the Express, and it's available at the master tool. So you don't have to it's a feature that it's embedded with our whole family, from Express 300, our basic one, to our Express 340 that I have, this Express that I have in my hands, this functionality that we will see, the web server. This library, it's open to use and free to use with this, this Express. So here we have the library, the input, comments, and a whole documentation about the library. And these sample programs here, it's available to download and to test with the hardware with no problem. You can contact our partner Afro, and the Afro guys will send this to you, because this is available to use exactly as a sample. Okay. Okay, keep moving here. Any questions about this application? I will ask you, if you have some questions, please just send the question if you want to chat these questions. As you know, I have two colleagues, Mr. Stout and Mr. Trying. It's in our chat. It's in this session, and he can these guys can reply your questions, or if you have some questions, please just ask. Okay. Okay. Let's talk a little bit about SQL database library. The SQL database library, the MS SQL client library, allows a direct connection between a controller device to a Microsoft SQL Server database. After the establishment of this connection, user can perform write and read operations on a SQL Server database using structured test query language, SQL. So here I take a print. We can send information actually using a string to the database, and the database can return to us for example, if I'm doing, for this case, I'm doing a query, so I'm asking information from the database, but I can insert to information. So it's just a string that I can send to the database. And here you have the, for example, the IP, the login parameters, IP, the port, TCP port, the user of this database, and the password, and of course the database that I will connect in this system. So again, this library, it's open to use. Let me just show you here. You just need to insert this library. SQL library. So I'm inserting this in my project. Here it is. Again, we have inputs, a graphical, inputs and outputs to feed and the return, and the documentation about this library, simple to use. And of course, we have, as we have in the MQTT, we have a dedicated user manual to do this. So it's available to download these manuals too. Okay, let's pass into our web server feature. Actually, this picture is came again just to present exactly a way to connect the web server.
Excuse me, Morris.
Okay.
Thomas, sorry. Related to the database, do you using another libraries? Do you have other libraries for other commercial databases, or only SQL Server?
Only nowadays, today, we have just the library to SQL Server, but it is in our roadmap to produce, for example, to connect to Oracle, MySQL, or Apache, and other database, commercial database. But nowadays, available to use just the Microsoft, the MS SQL.
Thank you.
You're welcome. So returning here, we have the web server embedded, and actually for this, we will do a hands-on practice here. I will create with you the web visual. Let me just so about the web server. Flexibility in the development of small and medium applications. System that allows the creation of supervision and monitoring screens without the use of SCADA software or HMI in this case. Embedded in the controller's memory, it's possible to access the screens through a web browser directly from the computer, tablet, or smartphone. Control and supervision application on a single programming software. Of course, we have a cost reduction in the project. But how to do this? Is it too difficult? So let's create a project together. As you can see here, I have the same connection that I have in my, the same project that I'm connected, and we talk about the MQTT. So I will close these POUs here. And we will disconnect, of course, from the controller.
Yeah, 8
Oh, there is someone to want to do a question? Hello?
Is there some noise from coming?
Yeah. Okay, let's keep going. So let's create a project here. I will use the same project that we are using to connection to the MQTT, but I will insert now a visualization manager. So I will just check these visual symbols to use the library that it's embedded in the master tool. So I'm inserting the library inside the master tool here. Okay. Okay. So here we have settings. Oh, it's inserting. Okay. Settings, dialog box, default hotkeys, visualizations, and user management, font settings. We have a whole options and tabs to configure it. But let's focus in our application. Here in the advanced, we can set the maximum number of visualization clients. So I will set this to 100. Here at the WebVisu configuration, we need to, of course, create the first an initialization screen on the first screen. So I need to connect. Here is the name of HTML file. So I will connect using this, what I put here. I will let the default. And just the scaling options as I will connect using my screen here. I will let it in fixed, not in an anisotropic or isotropic connections. It's just scaling the objects that I will insert. So I create this management. Now I need to insert, of course, a screen that we call here visualizations. So I will add with the name visualization, no problem. Okay, so here what I will insert is a potentiometer. Okay. And this potentiometer, this is the scale, the configuration of everything that we have here. And I will connect. Do you remember? Let me just reopen. This throttle. So this throttle, it's just, in this case of MQTT, I will just read the information about the throttle. But now, in this hypothetical project that we are doing, this potentiometer will set the throttle. So what I will do, it's exactly this. I will connect this information, application, user, MQTT, and here I have analog output 1 to WebVisu. So I will connect this information here, just connect this, and This information will send information to the analog output in my controller. I create this variable before, of course, inserted in a GVL, this here. It is. So I just connect this information here, and I will insert together with this just a test field to check the information about this. Where is this? Third element. Second. Testing variables. I will connect to the same variable. Here. And of course, I need to put that tests here. Just an information that will be in a decimal point. Okay, so almost done. What I need to do now is returning here to WebVisu and choose this screen that I create as the screen of the first screen, the start visualization screen of my systems. So save and log in to send this to our system. So now I'm downloading this web server with this screen. Okay, no, I don't wanna to download source code. Okay, my CPU it's in stop. I will start. And of course, as I download the software, I need to reconnect the systems. So the host name here in the MQTT, we are returning just to connect again to our cloud here. Let me check if it's connected. Yep, we are connected with no errors. Okay. So what I will do now is checking here, first point. Let me just reopen this and test the connection here. Yeah, it's connecting. I can change this. Okay. Now, how can I access the system? And I will open another one here. I will type the address of my Express 7.7, the Ethernet port, and we can check just here. 7.7, it's the Ethernet port from my Express. 2 point. Actually, I had the address, the path here, but 8080 it's the port, and WebVisu dot or point ATM. Do you remember from here? We have this WebVisu point ATM. So, and now I will open this. And here we have the potentiometer. So what I will do now is open this screen and check if this throttle is receiving the information from my web server. 66. And you are receiving too in your, because I'm publishing this information to the cloud. So what I'm doing, using the web server embedded, the WebVisu, sending this information to my analog output here, right? So I'm writing this, and this is writing in the analog output. And if I'm going to MQTT publisher here, I'm publishing the analog output. Where is this? Analog input, analog output. Here, hours, here, 7.3. So I will return here, 7.3, and I will change this, for example, to 56. We have 56 here, and we have 56 here. So again, sending information using the WebVisu to the controller, setting the throttle, and this throttle is being published to everybody in the world connecting to this cloud. Okay? Okay, so just to give a spoiler from the next session, the fourth that we have next week, I'm using here okay. I'm using here a modem connected. And this modem is connected to this IP in the world. So what I will do is exactly copy this and open a new tab here and put the same address, webvisu.html. So I'm connecting in my Express using the 3G, 4G modem dongle connected in the USB. And I can operate to this. So I can access the WebVisu, and now you can access the WebVisu because I will send this information to the chat. Where is the chat? Here, here. So I send you another path in the address, and I will open here again the path visualization, so the dashboard. And thanks a lot. You are operating the system from where you are. So of course, you are using this 91 and sending information. So I'm receiving your information using the WebVisu, the web server embedded through the modem 3G, 4G. And I process this information that you are changing and pick this information and send to the dashboard. So as you can see, I'm just using an Express, and you can do everything that I did here with the libraries and the features that we have. This information about the 3G, 4G dongle, of course, we will talk in the next session, next week, how to do this and how to access and what we can do using the 4G, 3G and 4G dongles. So this is just a spoiler about this functionality actually, and you can see that it worked very fast and very well. Okay, to finish, just return here. I have some application success stories here, just to share with you. Here we are using this in Brazil. This is a success story. We have a soy farm. We have a biofertilizer plant inside the farm, and we can produce our fertilizer inside this farm. So biofertilizer production on farms. To ensure that only valid products are used, the systems relies on sending barcode data to the companies in headquarters. So the headquarters of the provider of this plant, it's of course outside this farm, but you can monitor everything about your biofertilizer plant and allow information, allow production. And only then it does release a batch of production on the farm. Local operation is done through a web server, WebVisu. So we are using the same type of sample, and inside of this small biofertilizer plant, we use an MQTT, an Express, I'm sorry, using the MQTT can open to connect some drivers here, and web server to allow the operation in local operation actually. Here another success story about a labeling machine. So we have an Express connecting using inside of this Express, of course, the local control. We have math algorithm to synchronize motors and conveyors, high-speed processions. So we have here 41 microseconds per 1,000 arithmetical instructions, more than 20 times faster than competitors S7 1200 and M221 from Schneider and Siemens. 100 kilohertz pulse train outputs for step motors here. And we are connected using CAN open to some inverters and using the Modbus TCP at the same time that we are using the MQTT library to send information here and mounting performance and OOE information, creating this dashboard to manage this information. This we talk, I think, in the first session. This monitor of diesel generators and propellers using the J1939 and QTT features. This is a CAN.
Sorry, Torres, I have a question about the information you mentioned that in the last slide about the benchmark of you are faster than Siemens S7 and Schneider Electric. Do you have a benchmark or studies that document this type of achievement or benchmarking? Or?
Yeah, we have in our specs, in our datasheet, we have the information about the high-speed procession, right? And we have a benchmark comparing these controllers, the S7 and the M221.
This is done by independent party or third party, or by yourself?
Actually, it's if I understand well, we compared we compare our specs, our data sheet with this data sheet of the competitors, and so we can comparing.
Internal
Yeah.
exercise, right?
Yeah, it's here's Fernando Trine from Altos. Yes, it's usually we don't share this kind of information in public data sheets, but every kind of benchmark we do in terms of processing power, the ability to handle multiple protocols and those things, we do with our partners. They could be local integrators or even some end customers, but we are responsible for the information. So we can provide that to you. It was done by somebody else, but it's not an independent group. We compile, we receive all the information, and of course, then we bring up the tables and everything.
Sure. Thank you.
Thanks, Mr. Trine. Okay. Here, another success stories about using the J1939 CAN and MQTT using the 3G, 4G modeling to send information. It's an environmental project that aims to send data from the diesel engines of vessels that navigate this road basin. Here, another one, success stories. It's irrigation systems. We are using an Express 315 and tree inverter communication, CAN open, MQTT for the cloud to start and stop via mobile phone, Node-RED integration for a dashboard. Weather, this is the main point, the weather forecasting assistant decisions, making for more or less water injection. So we have a PID controller for pressure in the water. Basically, the result is longer pipe life with fast pressure control, I'm sorry. Reduced water consumption, approximately 35%, and planning to water the plants up 3 days in advance, of course, because I'm receiving the forecast. Okay, thank you. I think we can talk a little bit if you have some. I'm seeing here we have some questions. Okay, for Mr. Abdul. Oh, thanks. Okay, folks, I'm open. Me and my colleagues, Mr. Fernando Trine and Mr. Fernando Stout, we can talk a little bit more about the presentation, or if you have some questions, I can show you a little bit more about the software. We are open.
Yes, I have a question here about you mentioned the Industry 4.0 and so on. Regarding the IT/OT convergence, do you have any other examples in addition to the examples that you mentioned related to MQTT and OPC UA? Do you have other examples related to the industrial networking, related to edge analytics or edge computing? All of this is you are more focusing on these two protocols. Do you have other examples or other stories around Industry 4.0?
Well, I bring some these 3 points actually just to show. In my opinion, these 3, it's very nice. But of course, we have some other samples, mainly in the digitalization, because basically we have the Express. It's our we are calling this an edge controller, because the Express talk can communicate in many protocols, and you have embedded I/O, and you can send information and you can convert using this as a gateway. So for example, we have some applications that we are using Ethernet IP to connect in a device for example, a controller, temperature controller, catching information from this temperature controller through the Ethernet IP, sending information to the, using the Modbus RTU to an HMI, and concentering this information to send via, actually in this case, OPC UA to a SCADA, a control central, to the central of operation. This we are using some company in Asia. And so actually we have here in Brazil, we are using in the Express in some equipments, as for example, trucks. We are putting the Express to collect information from some trucks and sending this information exactly using the 3G and 4G dongle through the MQTT from a company here to just collect information about the systems of these trucks, for example, the refrigerators of the container, and this is transport logistic actually company. So yes, we have, and we can share with you more success stories. But actually, I picked just these three because this is, in my opinion, it's very, very.
Thank you very much. I interested to know more about your use cases related to Industry 4.0, not only related to these 3 points, but other points or other stories that related to the Industry 4.0 and the IT OT convergence, and how is your company seeing this kind of integration and convergence? Yeah. As a consultant responsible for this kind of integration, I'd like to understand more about this OT-IT convergence, and what is your roadmap, or what is your vision in this area to integrate with the IT people or IT domains, and so on.
Actually, it's as we can see, it's this is increasing very fast. Exactly that why we have these protocols inside a total industrial. For example, if we talk about the automation, I think 10 years ago, 15 years ago, we have the operation technology or the automation guys just focus in his own network and his own systems. And we never thought if I'm returning 15 years ago to connect, for example, a controller straight to a database. So it's not 15 years ago, it didn't make sense for us. But nowadays, we can see that it's actually we are moving to these kind of applications. Exactly the overlap that we have between the IT and the OT. So actually now we are seeing that the guys from IT that came to the OT application will see something much more friendly to programming, because we have embedded structured test and not the ladder and the automation kind of language that we used to use before. And at the opposite, we have the OT guys, the automation guys, moving to know a little bit about this kind of stuff, as for example, TLS, cybersecurity, and the MQTT, of course, the web server embedded in an automation control. So actually, we are seeing these. Every day we have a new possibility, and every day we have a new information about some need exactly focus on this kind of applications. So we are seeing this with a very good eyes, because we have of course, Altus is 38 years old in automation, and we are moving since, I think, 4 years ago, moving exactly to complete the automation with the IT, and the opposite is true. And I don't know if I'm clear.
Yeah, very clear. Yeah, I would like also to if you have more information about what is your vision about cybersecurity, and also what are your vision, or what you are, how you are seeing the industrial networking. Do you have similar, for example, partnerships on this area, two areas related to cybersecurity and networking with IT vendors like Cisco, like yeah, similar to what other OT vendors doing, like Siemens or like Rockwell and so on. They starting to have some kind of agreements with these IT vendors related to the network and security, to having an integrated solutions and integrated hardware and software that can fulfill this OT-IT potential integration or conversion in the coming period or coming years.
Actually, we are planning to embed it, to produce embedded in the Express. It's again in our roadmap.